The image was published without alarm. A soft red smear on a black field released by NASA with the words, brighter, more compact, and more chemically enriched than expected. That was the polite sentence. Here is the harder one. What you are looking at is a galaxy called MOM Z14, and the light in that pixel left its source 280 million years after the Big Bang. That is roughly 2% of the age of the entire known universe. It should not exist yet. It is too bright, too heavy, too full of elements that require dead stars to have already lived and died. And it is not alone. Webb has now found hundreds of structures like it. The Big Bang isn't over. But the confident version you were taught is quietly dying in real time, and the telescope built to confirm that version is the instrument now writing its obituary. Before I keep going, tell me where you're watching from and how old you were the first time someone told you the universe was 13.8 billion years old. Because whatever number you were handed as a child, the map that came with it just started smoking at the edges. I want to know how far this story has traveled. Drop your country in the comments. Then come back, because what I am about to walk you through is not a rumor and it is not a conspiracy. It is what the peer-reviewed literature has been saying, in careful language, since the summer of 2022. And the careful language is the part I want to translate for you tonight.
MOM-Z14 was confirmed at a spectroscopic redshift of 14.44 in a paper by Rohan Naidu and colleagues in the Open Journal of Astrophysics in early 2026. That number, 14.44, is not decorative. It places the galaxy at roughly 280 million years after the Big Bang, and it makes it the most distant galaxy ever spectroscopically confirmed. Its inferred stellar mass is around 100 million suns, compact, luminous, and chemically enriched with elevated nitrogen, which is a signature that requires generations of massive stars to have already been born, burned through their fuel, and exploded in under 280 million years. The paper's own co-author used the phrase, a growing chasm between theory and observation. That sentence, from inside the field, is the softest possible way to say what the numbers actually mean. Because MOM-Z14 is not the first, it is the fifth or sixth in a chain of confirmations that keep pushing the same problem. Bright galaxies at redshifts of 14 to 15 now appear more than 100 times more abundant than the consensus models predicted before Webb. Not slightly more, 100-fold more. That is not a rounding error you smooth over in a follow-up study. That is the difference between a theory that fits reality and a theory that has to be rebuilt. Here is the part that should bother you. The light in that pixel has been traveling for more than 13.5 billion years. It left before the Earth existed, before the sun ignited, before any atom in your body was assembled inside any star. It has been in transit longer than the ground you are standing on has existed. And when it finally arrived at Webb's mirror, it showed a structure that our best theory said should still have been a formless cloud of hydrogen. This is not a single anomaly. This is a pattern, and every rescue proposed so far has opened a new hole in the ceiling above it. The version of the beginning you were taught in school is elegant. A hot, dense state, a rapid expansion, cooling, a period called the Dark Ages when there were no stars, only neutral gas. Then, slowly, the first stars ignited. Small, messy protogalaxies formed. They merged. Over hundreds of millions of years, and then billions, structure grew. Big galaxies came late. Spiral arms came very late. Heavy elements had to be forged inside stars, and stars had to die before anything like our Milky Way could exist. That is the framework. It has a name. It is called lambda cold dark matter, or ΛCDM, and it has been the reigning cosmological paradigm since the late 1990s. Webb was supposed to confirm it. That was the pitch. $10 billion, 30 years of planning, a mirror the size of a house folded onto a rocket and unfurled 1,000,000 miles from Earth. Look far enough back, and you would see the smudges the small, faint, irregular baby galaxies the models predicted. What Webb actually saw in its very first year of operations was different. It saw bright, compact, structured, chemically mature galaxies where smudges were supposed to be. And the reaction inside the field before the press releases were rewritten for calm was closer to panic. In 2023, the astronomer Ivo Labbé led a team that published in Nature what they described as being mind-blown, kind of incredulous. They had found 6 candidate galaxy systems, seen 500 to 700 million years after the Big Bang, that appeared to weigh more than 10 billion times the mass of the Sun. One of them looked heavier than the Milky Way, a galaxy that has had roughly 13 billion years to grow. In the same window, another astronomer, Michael Boylan Colchin at the University of Texas, published in Nature Astronomy a formal analysis flagging tension with ΛCDM at a level that would, in any other subfield, be treated as a crisis. That was the field's own language. Then the messaging changed. To understand why this matters, you have to understand how galaxies are supposed to be built. In the standard picture, everything starts with tiny density fluctuations in dark matter. Those fluctuations collapse under their own gravity into invisible scaffolds called halos. Gas falls into the halos, cools, and forms stars. The halos merge, the galaxies inside them merge. Slowly, over deep time, structure emerges. Small halos first, bigger halos later. Mature spiral galaxies with organized disks, much, much later. The rate at which this happens is not arbitrary. It is set by the physics of gravity, the density of matter, and the efficiency with which gas can turn into stars. Those quantities are measurable. Those are hard ceilings. Think of it as scaffolding first, bricks second, buildings third. You cannot have finished skyscrapers before the scaffolds have finished going up. The dark matter halo is the invisible frame every star, every planet, every atom you're built from was assembled inside. Every breath you take moves through molecules that were forged inside stars, that lived inside galaxies, that lived inside halos. That whole chain has a construction timeline. And what Webb is now showing us is finished frames, massive, mature-looking galaxies, in an era when the scaffolding should barely have begun, more than 100 times more abundant than the model allowed. That is not an accounting error. That is a ceiling being pushed through. And this matters for a reason most people don't stop to think about. Every atom heavier than hydrogen or helium in your body, every carbon in your DNA, every calcium in your bones, every iron in your blood, was manufactured inside a star and released when that star died. That process takes time. Stars live for millions or billions of years, depending on their mass, and only the most massive ones die quickly enough to release heavy elements early. To find a galaxy already rich in nitrogen at 280 million years after the Big Bang is to find evidence that entire stellar generations had already lived and died before the universe was old enough for that to be possible under the standard picture. You are looking in that faint smear of light at the ashes of stars that shouldn't have had time to burn. The comfortable interpretation is that galaxies just formed a little earlier than we thought. That sentence sounds reasonable, and it is the one you will hear on television, but a little earlier would still fit the model. What Webb is showing is not a little earlier. It is a categorically different formation speed. JWST-GS-Z 14-0, another confirmed galaxy at redshift about 14.3, contains something like 500 million solar masses in stars and shows evidence of a burst of star formation lasting only a few million years. OM-Z14's elevated nitrogen requires massive stars to have already lived and died. Our own Milky Way took billions of years to build up the heavy elements you are currently made of. Webb is finding galaxies that appear to have run the same clock roughly 50 times faster. The model didn't get the timing slightly wrong. The model didn't leave room for what we are seeing. And once you accept that the timing is broken, The next question is worse, because if a single galaxy is too early, that is a mystery. If they are everywhere, it is a pattern. And what Webb has been quietly cataloging is not a handful of exceptions. In 2025, a team at the University of Missouri, led by Bangjeng Sun and Haojing Yan, published in the Astrophysical Journal an identification of roughly 300 unusually bright dropout candidates, objects that appear to be galaxies far too luminous for their apparent epoch. The JWST Advanced Deep Extragalactic Survey, or JADES, has now cataloged thousands of high redshift galaxies. The samples are no longer anecdotal, they are statistical. In January 2026, a team at Texas A&M reported a 5-galaxy merger already redistributing heavy elements 800 million years after the Big Bang, in a compact region forming stars at 250 times the rate of typical galaxies at that time. That is not simple two-body merging. That is a construction site running centuries ahead of schedule. Also, in 2025, astronomers identified a galaxy nicknamed the Big Wheel, a fully organized spiral disk in the first 2 billion years of the universe, in a crowded region of space where mergers should have destroyed the spiral arms. Then, in a 2026 study led by Ben Forrest at UC Davis, Webb detected a massive galaxy less than 2 billion years after the Big Bang that showed no rotation at all, behaving like a mature, spun-down system when it should still have been spinning up. Every one of these is another observation the standard timeline has to absorb. Individually, you can excuse them. Collectively, the excuses are running out. And the sentence being softened over and over is this one. The same anomaly is showing up in every corner of the sky Webb points at. This is where the story stops being about one dramatic discovery and starts being about a systematic mismatch. The mismatch is not resolving, it is compounding. And compounding anomalies, in the history of physics, are how paradigms end. But here is where the story truly stops being about galaxies. Because Webb also found something the pre-2022 catalogs of astronomy had no clean word for. They are called the little red dots. About 300 have been identified so far, and they appear in Webb's deep field images between roughly 600 million and 1.6 billion years after the Big Bang. Small, compact, ruby red. Then, around the 2 billion year mark, they vanish. They do not fade gradually. They do not merge into recognizable galaxies. They disappear from the surveys as if the population terminated. Nobody has a settled explanation for why. They also broke categorization. Their spectra suggested masses too heavy to be normal early galaxies. Their light showed features that look like the atmospheres of stars, features called Balmer breaks, even though supermassive black holes were also implied by the way their emission lines were broadened. They lacked the X-ray and radio signatures that normal supermassive black holes emit. And they appeared in numbers 10 to 100 times higher than the known quasar population at similar epochs. That last figure is worth pausing on. Quasars, the brightest active black holes in the universe, are rare. The little red dots are common, and nobody knows what they are. The rescues that have been proposed for them include, in the last 2 years alone, black hole stars, black holes wrapped in dense stellar-mimicking gas cocoons, described by Rohan Naidu and colleagues in 2026. Supermassive stars in their final pulsational phase, from Devesh Nandal and Avi Loeb in the Astrophysical Journal. Direct collapse black holes seeded from dark matter halo collapse, and primordial black holes formed in the earliest moments of the universe. Each of these explanations is itself a departure from the pre-Webb standard picture, and they are not compatible with each other. Imagine looking through the sharpest telescope ever built and finding objects so common they clutter your images. And yet, in your entire library of physics, there is no clean word for what they are. You are staring at hundreds of things that have no name, The public story is that scientists have solved the little red dot mystery. The reality, documented in Nature, in Science, and in the Astrophysical Journal across 2026, is that the field has proposed at least 5 mutually exclusive solutions and is still arguing. Each solution is presented in the press as if it were the answer. Each is treated in the journals as a working hypothesis. That gap between how it is announced and how it is actually held is the shape of the whole crisis. And if you thought the objects themselves were the problem, wait until you see what is inside them. Because the second half of the Webb-era crisis is not about galaxies, it is about black holes. In 2025, an ESA-led team using Webb confirmed an actively feeding supermassive black hole inside a little red dot, called CANUCS-LR-D-Z 8.6, just 570 million years after the Big Bang. Other Webb surveys have found what astronomers call overmassive black hole systems, galaxies where the central engine is heavier, relative to the host, than any relationship measured in the local universe would allow. And to explain how these black holes got so big so fast, theorists have had to bend or break a limit called the Eddington limit, the physical ceiling on how quickly a black hole can consume matter under classical accretion. The Eddington limit exists for a reason. When a black hole feeds too fast, the radiation from the infalling gas blows the rest of the gas away, choking the meal. Under standard conditions, that sets a ceiling on growth rate. But the black holes Webb is seeing at 500 to 700 million years after the Big Bang would have needed to grow through that ceiling for hundreds of millions of years continuously, or to have been born already huge. To make either work, theorists including Fabio Picucci and colleagues have proposed direct collapse black holes, objects that skipped the stellar death pathway entirely and formed from collapsing gas clouds of tens of thousands to hundreds of thousands of solar masses. That mechanism has never been directly observed. It is invoked because the alternative, that these black holes grew by ordinary accretion, is not physically possible in the time available. This is not just an astronomy debate. It is a supply chain problem. Every supermassive black hole visible in the modern universe had to grow from a seed. Webb has shown the seeds were already too big, too fast, and too many. The manufacturing timeline of the cosmos does not close. Pre-Webb, the earliest known bright galaxy was Hubble's GN-Z11, at about 400 million years after the Big Bang. Webb has now pushed that back to 280, and every push has made the mass versus age problem worse, not better. Every new record does not confirm the model. It stresses it further. Try to hold the scale of this in your head for a second. A supermassive black hole in the local universe, the one at the center of our own Milky Way, for instance, took roughly 13 billion years to reach its current mass of about 4 million suns. Webb is finding black holes hundreds of times heavier than that, present in the universe when the universe was less than 1/20th of its current age. It is as if you looked at a construction site an hour after work began and found the tower already halfway to the sky. Something is either adding mass through mechanisms we don't understand, or the mass was there from the start. Both possibilities rewrite chapters of physics that were considered closed. So if the observations keep contradicting the model, why does every headline still open with the words "according to the Big Bang"? This is the uncomfortable part. Because there is a pattern in the coverage, and once you notice it, you cannot unnotice it. Every impossible galaxy headline is followed within months by an "actually, it's fine, we found a fix" headline, usually using the same telescope's data. NASA's 2024 release, based on a study led by Katherine Twarowski entitled "Webb Finds Early Galaxies Weren't Too Big for Their Britches After All," is a textbook example. A January 2026 Nature study by Vasily Rusakov and colleagues revised the black hole masses inside little red dots downward by roughly a factor of 100. arguing that dense ionized gas cocoons had been artificially broadening the spectral lines used to weigh them. Both of those revisions were real science. Both narrowed the crisis. Neither made it go away. I want to be careful here because I am not saying scientists are lying. Science self-corrects. New data changes interpretations. That is real and that is healthy. What I am saying is that a second dynamic runs parallel to the honest self-correction. Agencies protect flagship program narratives. ΛCDM has decades of successful predictions defending it, so the paradigm is not surrendered lightly. Press officers write for calm, not for alarm. Funding cycles reward reassurance. So the public-facing tone lags what the specialist literature actually says. Sometimes by a year, sometimes longer. And viewers of general science coverage end up hearing the smoothed-over version months or years after the community has moved on. In July 2026, Quanta magazine described a meeting at Helsingør in Denmark, where more than 100 researchers gathered specifically to discuss the puzzles of the universe's infancy. The professional community is not calm, the public messaging is. That gap is not accidental. It is a design choice about narrative control. And the current cycle, anomaly discovered, panic in the field, PR calm down, partial technical rescue, next anomaly, is not stable. Each rescue is thinner than the last. Each fix requires more assumptions than the one before it. And that is exactly the pattern the history of science recognizes as pre-collapse. Think about how this plays out in your own experience of science news. You see a headline, Webb finds impossible galaxy. You feel a small jolt. A few months later, you see another headline, scientists explain impossible galaxy. You relax, you move on. The story feels closed. But if you follow the citations, if you read what the second study actually claims, you find that the explanation usually reduces the anomaly rather than removing it, and often requires a new assumption to work. That is not the same as solving the problem. It is trimming the problem down to a size that still fits inside the model. And the trimming itself is telling you something important. The model in its original form cannot absorb what Webb is showing. Which brings me to the part I have been building toward. Because eventually, if the anomalies keep coming, the rescues stop being small. Look at what the field is now genuinely proposing in peer-reviewed journals to explain what Webb is seeing. Rescue 1, faster and more efficient star formation than any galaxy in the local universe demonstrates. Physics currently unexplained. Rescue 2, feedback-free star formation, proposed by Andrea Ferrara and colleagues, in which the normal regulatory mechanisms that slow galaxy growth are simply switched off in the early universe. Plausible. Ad hoc. Rescue 3, direct collapse black hole seeds from Pacucci and others, which rewrites how the first black holes were born. Rescue 4, self-interacting dark matter halo collapse from Fengzhou Jiang and colleagues in a 2026 study covered by AAS Nova, which modifies the physics of dark matter itself to permit massive seed black holes. Rescue 5, primordial black holes formed in the earliest fractions of a second after the Big Bang, an exotic population that has never been confirmed. Rescue 6, modified cosmology, early dark energy variants, or alternatives to ΛCDM entirely. Look at that list. Now notice something. These are not compatible with each other. The field is not converging on one answer. It is diverging into several, each of which requires a real change to physics as it was written before 2022. Some of these rescues modify dark matter. Some modify star formation. Some modify the earliest instance of the universe. They cannot all be right. And the fact that so many are seriously proposed at once is itself the diagnosis. When a paradigm is healthy, anomalies fold into it. When a paradigm is failing, anomalies fracture into competing explanations that agree on nothing except that the old model is not enough. The early galaxy problem does not stand alone. There is also the Hubble tension, the running argument over how fast the universe is expanding today. in which two different measurement methods give two different answers and refuse to reconcile. Add Webb's early galaxies, add the little red dots, add the overmassive black holes. The standard model of cosmology is still standing, but it is being held together by hands, not by data. Astronomy has been here before. Ptolemy's geocentric model kept a broken picture of the solar system alive for centuries by adding one epicycle at a time. Each patch made the predictions technically survive. Each patch preserved the paradigm for another generation. The model still eventually fell, and when it fell all at once, replaced by something the older astronomers hadn't had the tools to see. That is how paradigms actually end. Not with a single decisive observation, but with an accumulation of small ones the old framework can no longer digest. The astronomers who lived through the Copernican revolution did not experience it as a single moment. They experienced it as a slow, uncomfortable realization that their tools had outgrown their theory. So what does that leave you with? What do you do with a picture of the universe that keeps needing new hands to hold it up? Go back to the image, the MOM-Z14 pixel, light older than every atom in your body. When you first saw it, it was framed as a triumph, the newest record, the farthest confirmed galaxy, another beautiful step forward. It is those things, but now you can see it as something else at the same time. It is evidence that the map is wrong in a way no one has yet drawn a better version of. It is a photograph, and it is also a warning shot fired across the standard model. I want to be honest about what this is and what this is not. This is not proof of anything supernatural. This is not proof that scientists lied. The Big Bang model, in its broadest form, has predicted an enormous amount correctly. The cosmic microwave background, the ratios of the lightest elements, the large-scale expansion of the universe. Those predictions are still standing. But the confident textbook timeline you were taught, the specific story about how galaxies grew, how black holes assembled, how mature structure emerged from the dark ages, that particular version is being quietly rewritten in real time in the pages of the same journals that once defended it. The rewriting is happening in careful, cautious professional language, and the softening between what specialists know and what the public is told is real, measurable, and consequential. Here is what the evidence taken together actually says. Confirmed galaxies at 280 million years after the Big Bang that are too luminous, too compact, and too chemically mature for their age. Roughly 300 little red dots that fit no existing category. Supermassive black holes present when the universe was less than 600 million years old. Fully formed spiral disks and non-rotating mature galaxies in the first 2 billion years. Multiple mutually incompatible rescue theories published in Nature, in Science, and in the Astrophysical Journal in 2026 alone. And the professional community's own recurring phrase appearing in paper after paper. A growing chasm between theory and observation. This is what a live science looks like. This is what watching a paradigm strain in real time actually feels like from the inside. In your lifetime, possibly in this decade, you may see the standard model of cosmology either rescued by physics that has not yet been written, or replaced by something the pre-Webb generation did not have the data to see. Both outcomes are consistent with what is happening right now. Neither of them is the calm story you have been handed. Both of them are more honest than the story you have been handed. And here is the part I want you to sit with before the video ends. The universe is not obligated to be comprehensible to us on our schedule. Nothing about the standard model of cosmology was ever guaranteed to be the final word. It was our best attempt, made with our best tools, over decades of careful work. Webb was not built to break it. Webb was built to test it. And the test is coming back with results the test makers did not expect. That is exactly what a working instrument should do. The failure here is not scientific. The failure is in the translation between what the specialists are actually finding and what the rest of us are told about it. Because if you only ever hear the calm version, you will miss one of the most important moments in the history of cosmology, as it is happening. And it is happening right now, in your feed, in the papers being uploaded to Archive this week. In the images, Webb is downlinking as you watch this video. The Big Bang isn't over, but the version you were taught is dying quietly in the pages of the same journals that once defended it. And the telescope built to confirm it is the one writing its obituary. Let that sit for a second. Then look up, because the light that reaches you tonight, the ordinary starlight from ordinary sky, is the same kind of message that MOM-Z14 sent 13.5 billion years ago. And the message we are still learning how to read is this: the universe is older, stranger, faster, and less finished than the version we were taught. And whatever comes next in cosmology will not be written by the people who wrote the textbooks. It will be written by the ones honest enough to say the textbooks were wrong.